Another one of Python standard library features that I think it could be used more or should be used wherever you can use it is called default ticked. I've been using it a lot, and I've come across some of great places where this can be more useful if exploited well. And so yeah, this is going to be a little primer about what a default ticked is, why you should use it wherever you can, and some advantages. So essentially, default ticked is a part of collections module in Python, and what it does essentially is it's a version or it's an implementation of a dictionary that can be, or those curly braces, the hash maps in Python. It's a version of that, and it's essentially meant to initialize the keys, the unseen keys, to a particular value, which is called the default value. So here in this example, let's look at an example to make this point more concrete. Here in this example, you have a default ticked of lists. Now what that means is whenever it encounters a new key that it has not seen before, so if someone tries to reference a key that does not exist, it will automatically create an empty list. So this essentially is a constructor. It takes a constructor that can be called, a callable constructor, to create the object. So it will just run this constructor, and this constructor, of course, we know that if you create list, call list with curly braces, it gives you an empty list. So every time it encounters a new key, it will map this key to the value given by this particular callable object. So in this particular example, you're trying to map a color to all its possible values. So here yellow can take value 1 or 3, right? So you have to map this to a list of all the values it can take. So here they create a default dictionary of list and then loop through all of the values in the provided list or the pairs, and then this is called key and this is value, right? So they loop through all of them and they just directly reference the key. So essentially, working with dictionaries in traditional Python code, what you see is you check if k is not in dictionary, not in D, and if it is not in D, you initialize that particular key with a list containing one value, which is v, and if it already exists, you access that value and append the value to that list. Essentially, here we don't have to do that because we have a default ticked here. Now what it will do is it will encounter a key that it has not seen before. It will automatically create an empty list, and now you already have what you wanted. You have an empty list, you append the value there, and you get this result. Okay, so as of course you see that you cannot use it everywhere. You cannot just go and see everywhere there is a map and replace it with a default tick. That's not possible, because in some cases you use dictionary just to check for the existence of a value. You cannot use this to check for existence of a value, because you can do that, but not by this way, by referencing it. If you reference it, it will just create a key value pair. So that's one place you cannot use it. I cannot think of any at the top of my head, but of course there might be other cases. Let's look at another example. So here we have a simple hash map problem of counting the occurrences of integers. So given a list of integers, you have to create a hash map with key of a particular integer, and the value is going to be its count in the list. So if we loop through the list, we see if the particular key is present in the map. If it's already present, just increment the value, otherwise just initialize the value to 1. Now given this problem, how can we leverage default ticked here? So the only thing that we have to know is what default value we want to provide to a new key. So let's say if there is a new key, the new number is encountered first time. What's its count? It has to be 0 first, and once it's encountered, it has to be 1, right? So let's initialize all the new keys using this constructor, in constructor, which will give its default value as 0, and then we don't need this. Now look at the code and see how it works. So let's say 1 does not exist. It encounters 1, it says, okay, it does not exist. Let's call the constructor. Constructor will be 0. Constructor will give the value 0. Now the 0 is incremented by 1, and that is the one at this. That is the count of 1 at this point, right? Same will happen with 2. Same will happen with 3, and then it encounters 1 again. It will see 1 already exists and increment its value by 1, which is 2. So it should work. Okay, let me run this. Let me clear. I just ran this for sanity. So you see 1 is 2 times, 2 is 2 times, 3 is 1 time, and 4 is 4 times. Let's look at a more complex example related to graphs. So if you don't already know what graphs is, you don't need to worry. It's a very simple concept. I'll just give you what you need for this particular video. So given a list of edges, a pair of edges, you have to build a graph using a hash map. Now what is a graph? Essentially is a collection of nodes, and then it can be either directed or undirected graph. In a directed graph, you can travel in a particular direction. So for example, you can travel from I to j but not from j to I in a directed graph if the direction is given. If it's undirected, in this case it is undirected, and you can travel, so you can travel anywhere. So from, if there are two edges given, I and j, if they're connected, you can go from I to j and back from j to I. Okay, these are the edges. And now let's run this code just to see what the output is. So I did not save this, and let me run this again. So essentially you have to have a map containing the key, and where you can go, all the edges you can go from that particular key directly. So I can go to j, and you see k can go to I, so in turn I can go to k because it's an undirected graph. So what we have to, okay, I just clicked on generating documentation. Okay, cool. Okay. Wow. Okay. So how do we solve this problem here is we have to care about both the keys I and j. So if I can go to j, j can also go to I. So we have to treat both of them as separate keys. So here's exactly what we do. We loop through all of the edges. We first check for the first element of the pair. So we say if first element of edge is not in the graph, you create a list with the second element because I is connected to j. If it's already existing, you just append that with the new value. So next time if I encounters k, it will just get appended to the existing list. We repeat the same thing with j. If j is not already in the graph, you create a key with the value list and just one value there, which is the first value. If it already exists, just append there. Now can we use default ticks here? And if so, of course we can use, that's why it's here. Not a trick question. Something I have to think about is what value can we initialize the default tick to. So here you see we're using list, so it's pretty clear that we want lists. But will the empty list work? Let's see. To go from a traditional dictionary to a default tick, you remove everything except the else clause, the statement in else clause, to be more precise, right here. And let me just use default tick of list here. Okay, now let's just try to see how this works. Let's say it encounters I, it sees there is no I here, so now this will be replaced by an empty list, and then we call dot append j to an empty list, which is exactly what we needed. Now let's come here for j, get rid of everything else, just the statement in the else clause. Okay, now it comes to j, it says okay, j is not here. Now it replaces it with empty list, and then we call append to empty list with e of 0, which is I. So now we have two keys, I containing j and j containing I. What happens next time when we go here? Like we've directly skipped to the second statement, the I. Now it checks I is already there. Okay, no need to initialize anything. Now just append e of 0, which is k. Now we have the value of I contains a list with j and k. That is exactly what we needed. So let's see if this works. Let's save and then let's run this, and this exactly gives you the same result. So this is the power of default tick. This not only reduces the code size, if you're using a lot of dictionaries, you see how much redundant code you are writing. it also kind of improves readability in a sense. So someone looking at this code already knows that default it's a dictionary containing values of list, right? It's clear. You don't have to go down to the code and see what values are being appended, what values are being added into the list or added into the keys. You just know by looking at the code at the top. That's also another advantage. So yeah, these modules like functools, itertools, collections, and some other ones, related to concurrency, are really powerful modules in Python. And if you take full advantage of these, your code is going to be much simpler to read and also to maintain. So yeah, it's this just something that I thought about making a video on, because I have not planned this series out. This is like some of the things that are probably not available in the beginner's course, or it's somewhere like it gets lost because it does not belong anywhere. It is not an intermediate thing, it's not a beginner thing, it's just something that you should do. So yeah, that was it for this video, and see you if I have something next in the series. Bye.